Hi there, welcome to another chapter of the electric BMW 320i project. Well, getting a lot closer now. Finally got the Siemens spline adapter from EV West. I'll show you how I slapped that on. Been spending most of my time recently bottom balancing batteries, and I have 119 in my pack, so it takes a long time, but what I ended up doing was developing a automated system that I could do 4 at once, and I'll show you how that's going, and then maybe a few other things that are up. So let's take a look. Here's a look at the system I put together to do bottom balancing of the batteries. You can see I've got these little 3-digit readouts. They show the battery's already been drained down pretty far. This system was designed, as you can see, by these giant 200-watt tenth of an ohm resistors to be able to fully discharge the batteries. But you'll remember in my previous video I used these grid-tied inverters to pull down the batteries and put that energy back in my house. So this last part basically uses this system that I designed. Basically has a MOSFET that's controlled by pulse width modulation through Arduino DUI, and that also reads the voltage along with these little 3-digit readouts, and that runs on a program I have here that's logging everything. And this program also looks for trigger points and sets the pulse width modulation duty cycle depending on how the battery is discharging. So works pretty good. On top I have a precision 1 mega ohm resistor that's used as a bias for the input to the DUI, just to make sure there's no possible way to short the batteries, because that's one of the things I was concerned about, of connecting all these things together. And in fact I found that if something gets disconnected, like I disconnected one of these batteries, there is some short circuit and was left overnight and discharged some batteries down to like 1 volt. So now I'm working on that to bring that up to back up to 2.75 volts. But you can see it's already pulling down by indicating on the voltage. That will actually pull down below 2.7, and then the batteries are allowed to relax for about 30 minutes, and then it will start the pulse width modulation up again. And like I said, these can pull the full 30 amps. It's designed for that, although it gets rather hot, so it needs some kind of ventilation. I measured these resistors to get up to like 130 degrees C, so definitely need some air conditioning. But they're all set off on ceramic standoffs, so everything's isolated, and it seems to work pretty well. Been able to like I said, cycle about 4 batteries. Takes about an hour and a half, but they seem to be very stable after that. One interesting aspect about using the DUI for controlling the MOSFET is that, as you can see on the oscilloscope, I'm sending it a 50% duty cycle, which in theory should turn on that battery at 15 amps. But it's actually only running about half an amp, and that's because the DUI's 3.3 volts is just not enough to turn the MOSFET completely on. In fact, it's probably just idling it a little bit. But what this does is give great controllability over the current, because now the duty cycle is can be very, even all the way up to 100%. It only draws about an amp and a half, so very easy to dial these batteries right in. Another way to run this bottom balancing system, now that I have these little 3-digit readouts, is just to manually run it. The DUI is outputting the pulse width modulation signal, but there's no feedback to control that, so you just sit here and watch. And in this case, just doing the last little trim off of the batteries, pull them down to about 2.70, and then they'll rebound very nicely back to 2.75. So here's how the hard coat came out on the DMOC mount. Turned out to be a really nice dark deep red. I think it will actually stand out pretty cool inside the engine compartment. I think what I might do too is polish up the DMOC and make it shine, just to sit it up down there, since it's going to be in the center of the engine bay and very prominent, even though it's got to be the most ugly inverter ever. Big rectangular aluminum box. But I'll try and dress it up as much as possible. So here's a cheap way to heat up an interference fit. It's a $9 heat gun, and just let it blow on it for 20 minutes. This has been going about 15, parts up to about 200 degrees Fahrenheit. Probably shouldn't take much more than that. The garage is now a little bit chilly in here, so the motor's probably about 50 degrees Fahrenheit. So should make a go on pretty easily after it warms up just a little bit more. Okay, let's see this how well this spline adapter goes on. They're heating up for 20 minutes with the heat gun. Got up to about 300 degrees. Should just slide right on. Here we go. Right on. Now that's how a spline adapter is supposed to be on there. No play at all. See that? Wiggle back and forth, all it does is turn the motor. I don't think that can go on any further. So, successful. Finally got a spline adapter on the Siemens motor. So, next thing will be get that rebirth adapter, which is at the shop, to be able to accommodate this, and bolt that in, and then the motor go in, probably this weekend. Finally. So you can see, batteries, batteries, batteries. It takes a long time to get these conditioned. Fortunately, now I only have about 30 left, so about a third of the pack. And I'm already starting to put some of the batteries in the car, and that's going to be the next thing. What's left with the motor is I have to get that Siemens adapter, what's left of it, some parts machined out of it so that it fits the new spline adapter, and then that can all be bolted together and put back in the car. So I don't know, you know, vacation time coming up and all the holidays, have to see if I can get the car on the road before the first of the year. Would be nice, but not sure if I can do it. So thanks for watching, and we'll see what happens next.